All right, tangents. Before we get started, Franny, what can you tell me about a tangent? She's all over it.
A tangent is a line or segment that intersects a circle at exactly 1 point.
1 point. Beautiful. Anything else? What else do you know about it?
I don't want to go into, I took notes yesterday from the slideshow, but I want to go into the theorems, so,
You know why you're afraid?
yeah. Not really.
I don't want you to be afraid then.
If a line is tangent to a circle, then it's perpendicular to the radius at the point of tangency.
Good. Those are. Yes, ma'am.
This tangent is not the same thing as the tangent from trigonometry.
Beautiful. Nice. Did you see all that snow that's going to fall soon, though?
Yeah.
Yeah. It's kind of freaky when I'm teaching and things just fall through. It kind of looks like somebody jumped off the roof, so it's like bodies flying
Yeah, that
by.
was like an H1.
When in fact it's snow. That's never happened, just so you know. The snow's fallen. No one's ever jumped off. Yes, correct. They're different tangents. So this tangent that we're talking about is a physical object. It's a line, it's a segment, it's a ray, that kind of thing. The trig tangent is a function, which doesn't really pertain to this. Okay, so definition, perfect. We got that. The big thing to get out of that is the theorem, in that a tangent intersects the circle at a point of tangency and forms a 90-degree angle. And then, of course, what Matt said about the fact that they're different tangents, don't get the two things confused. And then there's that weird stuff about the tangent segments, which we'll get to in a second. But that's when you have a point outside the circle. So now we start moving that vertex around a little bit. Franny helped us with that already. We'll come back to this picture in the next slideshow. We don't care about the one on the left. There's the tangent intersects in 1 point, and then we'll come over here and talk about a secant in the next slideshow where it intersects in 2 points. Okay. What happens when it intersects in 3 points? Anybody know what that's called?
Diameter.
Nope.
Impossible?
1, 2.
Oh, I said impossible.
Impossible, correct, you can't do it. Okay, a line cannot intersect a circle in 3 points. So you got 0, 1, or 2, no other possibilities. Oh, this word also, trichotomy, what does that mean?
Tangent.
3, tri is 3, yeah. Do you know what a cotomy is?
That's Tomy is cut, I think.
Is it?
Yeah.
That doesn't really apply here.
I don't know what ho means.
Or cho.
Maybe like
Cho.
into 3 segments. I don't know.
Trichotomy means 3 possibilities.
Oh.
Okay, so dichotomy or binary, like light switches on or off. That would be a dichotomy. This is a trichotomy. 3 possibilities. Right? Yes?
Would a chord basically be a second
Secant?
secant? Just like one's a line segment, one's a line.
We'll get there.
Right.
Yep. Okay. So then there's the theorem that Franny talked about. It's perpendicular. That's probably the single most important thing to get out of the slideshow. It's going to form a 90-degree angle with the radius at that point, which is called the point of tangency. Okay. It's the point where the tangent hits the circle. Okay, then we got some examples here, which, blah, 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 blah. Notice that if I draw an AC, all of a sudden I get a right angle. Common mistake with tangents is that people put the right angle in the wrong place. They want to put the right angle in here at the central angle. It's not there, it's out here.
Hi, Joanna.
Keep your guard up, she leads with her right. Okay, good. Don't let her get inside. It's boxing terms. That's what Matt said. Okay, good. And the converse, we go backwards. If a line, well, it says right there. If it's perpendicular and intersects in 1 point, then it's got to be a tangent. Great. Let's get to this guy. So this one is a little weird. First of all, because I wrote in light blue, which you can't see, especially with the windows open. But the second thing is to recognize what's going on in that picture. There's a right angle in that picture somewhere. Where is it?
R.
Do we know? Angle R, correct. The other thing to realize is how long is OG, the original gangster? Do we know? I'm sorry?
5.5.
Why? Good, because it's a radius. Okay, and that's a commonly missed point here. You're going to see these situations where you have this line that comes from a point outside a circle to the center of the circle. and it's broken into two parts. One of those parts is a radius. The other part is this thing floating out in the breeze. Okay, so you have to be careful. Is that 9.5 the whole thing? Is that 9.5 this stuff out in front? And make a distinction, and also realize that that's a radius. And I don't remember the answer to the question, but basically we would do, you have to be careful here and recognize that R is the right angle because we want to see if 5.5 plus 13.6, 5.5 squared plus 13.6 squared is equal to 15 squared. Is it, by the way? No, so that's not a right triangle, which means it's not tangent. Because those two have to go together. It's got to be a right angle to be a tangent, and if it's a tangent, it's got to be a right angle. Okay. We don't care so much about common tangents. I just want to show you a picture here. If we deal with common tangents, it'll be more like the one on the left, where you've got a tangent to two circles at the same time. So if I do this, there's the point of tangency connected to the sun. Ooh, I missed. There you go. Okay, you with me? What kind of figure is that? Nope.
Quadrilateral.
Well, yes. Good. What kind of quadrilateral?
Inscribed.
No. I'll give you a little bit of help. Nope.
Never mind, it has two. Chat?
What kind of quadrilateral is that red guy? It's not a rectangle. Can't be a rectangle. Well, I shouldn't say that. It could be a rectangle. If it was a rectangle, what would you know about the two circles? They're the same. You're gonna say,
The
okay.
trapezoid.
It is a trapezoid, yes.
Why do you
Because
call it that?
that's how it's spelled.
I was trying to ask somebody a question and I said chord instead of cord, and they all laughed at me.
Why would they do that? That's the correct pronunciation.
Sure.
It's not this. That's something different. That's cord like you know, like a bungee jump with parachute cord. You don't bungee jump with a parachute cord.
That's how you spell like guitar chord.
No, isn't it like this?
No.
This? They must have spelled it wrong then.
Yeah, they did.
Because a guitar, it would be a guitar chord. It's not a guitar chord.
And now it.
You know, how many chords do you know on a guitar? It's ridiculous. This is the math. This is yeah, they spelled it wrong.
It's silly.
Or they spelled it in a unique way.
Could be.
Those artists, musicians, there's.
Yeah, they're weird.
Mr. Reed, how do you pronounce our state?
What state do we live in?
Confusion?
What U.S. state do you reside in?
Oh, the state of Illinois? Is that what you're talking about?
Well, I'll go to waste this course.
Okay. One thing I learned early in life. ISOS.
It's
CELE.
I actually started to think that it was.
All right, wait, we don't have time for this. Hold on. Shh. Okay, so getting back to where, oh, that's an eraser. Let's go back and put that in there. Okay, so that's parallel to that, so therefore it forces it to be a trapezoid. If, however, the circles are the same size, then we'd get a rectangle. That doesn't happen very often. You will see some problems involving this scenario with the common tangent. The secret to solving this problem is to turn it into two things, and that is a rectangle and there you go, and a right triangle. And so we can do all kinds of weird things with that. And you'll see some of those on the homework. This is silly. We don't care about that. Do you know the game Shoot the Moon?
No.
That'd be pretty hard
It's
to do.
it's that wooden thing with the two rods and the metal ball that you try to get the ball to roll uphill. Yeah, so that's a three-dimensional example of common tangents. So if you imagine that these are the metal rods that you slide in and out to get the ball to roll uphill, and then that would obviously be the big metal ball, and you get score points the higher you get up to the top of the hill. So, all right, just thought I'd mention that. Move on. Okay, so we have these things called tangent segments, and tangent segments, if I take the tangent and I chop off part of it, this thing that I'm left with that connects the point outside the circle to the point of tangency is called the tangent segment. And the theorem to get out of this is that those two tangent segments are congruent. So if I take any point on outside a circle, I should say, I put a point out here, for instance, and we call this Q. If I draw the tangents to the circle, something like that, point of tangency, then these guys here are called tangent segments, and not only are they tangent segments, but they're equal to each other. Okay. So you get kind of an ice cream cone looking thing on its side. Now, why are they equal? Well, we could go through the whole thing, but we don't have time today. We would actually draw that in, prove the two triangles are congruent by a variety of ways. You could do angles, side angle, hypotenuse leg would work well. Why is that equal to that? Why is that equal to itself?
It's the same as
Itself.
What's it called?
Reflexive.
Reflexive property. Hypotenuse leg, we're good to go. They're congruent. Now, anytime we have a point outside a circle, we shoot in the tangents, they will be congruent to each other. Okay, moving right along here. There's the theorem. Beautiful. This is called a walkabout problem. It's called a walkabout problem because you walk about the circle. How long is AE?
3.
How long is DC?
9.5.
9.5. How long are these? X would work just well. Just well? Perfectly well. Perfectly great. Excellent. Beautiful. Love it. How do we solve this? Oh, we know the perimeter is 50. Okay, so x plus 3 plus 3 plus 9.5 plus 9.5 has to equal 50. Solve for x. You're good to go. Okay? Yeah, that would give you 15.5. Okay. So, what do we know? All right, well, you tell me. In that picture, what do we know?
We know that
I feel like I'm running out of time, but I'm okay.
AB is the tangent.
I'm sorry?
Is AB the tangent?
Yes, it's actually the tangent segment.
Segment.
Yeah, What else do we know? Uh-huh.
AD and DC are all the same because they're both radii.
Okay. What else do we know? Uh-huh.
It's the right triangle.
Uh-huh. Here or here?
A.
Okay. How long is AD? Who's the iPad? How long is AD? Phil?
You could do x squared plus 6 squared equals x plus 4.5 squared.
Perfect. We don't know how long AD is, so she's chosen to call this x and x. And since the right angle is there, using Pythagorean theorem, we get x squared plus 6 squared is equal to x plus 4.5 squared. Oh, this would be a good opportunity to talk about this again. What's that squared?
X squared plus 9x plus 2x.
X squared plus
9x
9x.
plus whatever 4.5 squared is. Okay, not x squared plus 4.5 squared. Remember, you gotta FOIL this puppy or do first term squared, 2 terms multiplied together, double it, square the last term. Solve the quadratic. You might get 2 answers. You might not get 2 answers. This one you won't get 2 answers. But if you do get 2 answers, then you got to use common sense. If I get a negative angle, I can't have a negative radius. It would cause a gap in the space-time continuum and kill all of us. So you eliminate that so we don't all die. Okay? Any problems? A little bit, yeah, I saw that too. At least it wasn't a body. That would ruin my day. Well, it would really ruin their day, I think. Okay, so that takes care of tangents. Are we good with that?
Yeah.
Beautiful. All right, let's move on. What am I doing? I'm stopping this.
That could kill you.